Hello, welcome to Shahan Virtual Academy, and I am Professor Shahan. Today, I would like to teach you electronic configuration. Okay, thank you. So let's get started. Basically, what is electronic configuration? Let's suppose we have a sodium metal. It has uh, atomic number 2011 and atomic weight 23. So for the electronic configuration, atomic number is very important. Let's suppose we just see it. Its first shell, which is first shell should be your K nucleus. First shell should be your K shell. Basically, this is principal quantum shell. Principal quantum sh shells. Okay, basically this is which is K, L, M, and N. Okay, in the K shell there's only capacity of 2 electron to be filled, and there's 8 and so on. Okay, here is, if we talk about the sodium metal. So sodium has 2 electrons in the K shell, and let's talk about this is the K. Okay, this is the L. It's L shell. Almost sodium has 8 electrons. Okay, so it have only 1 electron in their last shell. So means that uh, it has 11 electron, 8. It means its configuration is K2, L8, and M1. Okay, now this is the electronic configuration of principal quantum energy levels, which is called shells. Okay, energy levels. Now shells, we goes to energy levels to sublevels. S, P, D, F. From the sublevels, we will go to orbitals. Each sublevels have different types of orbitals, and now the overlappings and hybridization. Okay, so this is the sodium metal. So if we just talk about how many electrons uh, and atoms can fill, how many electrons. So this is the basic formula, 2n square. Okay, how many electrons? The 2n square. N shows number of, okay, n shows the number of shells. Okay, 2n means 1 2 3. 3 multiplied by 3 and 2, 18 means 18 capacity. Means an element has the 18 electron capacity. Means M shell have 18 number of elements capacity. Okay, okay, because it's shell number third. Okay, so we talk about M. So we just put on 4 square because it's the fourth shell. It's a fourth number. First, second, third, fourth. Okay, so we just put on 32. It means N has the N shell, N subshell has N subshell has the ability to fill 32 electrons, and this has the ability to 18 electron. But how we can fill them, because while we just write it 8. So basically these shells, we can only show uh, N shells have the ability to fill 32 electrons, but we cannot show 32 electrons in their octets, in their shells. We just showing um, uh, only 8 electrons in their outermost shells. 8 electrons will remain on the outermost shells, while the other electrons will goes to the sublevels. Okay, now we just rub it and we just move on this. We talk about sodium. Okay, so how we can fill the sublevels? There's 4 types of sublevels: S, P, D, and F. S have capacity to fill 2 electrons, 2 electrons capacity, okay, while it has 1 orbital. It has capacity of 6 electrons to be filled, while it has 3 orbitals. It has capacity of 10 electrons to be filled, while it has 5 orbitals. Same 14 electrons its capacity have on f orbital, f sublevel, and it has 7 orbitals. Okay, S is 1, is only 1 orbital. Okay, SPDF, P basically the p orbital, the shape of s orbital is spherical. Okay, but the shape of p orbital is like that, lobes, just of lobes, and in 3 axes: the x-axis, y-axis, and z-axis. Okay, so it is px, py, and pz. So in each sublevel, in each orbital, there's only 2 electrons can be filled, and while in S there's only 1 orbital can be filled. Okay, in D there are 5. Most transition elements have d orbitals, and same in the 14. Okay, so this is basically all about, and basically these types of shells are can overlap, and we just move on. We will discuss now what is the rule of filling the electrons in these shells. I'm just talking about to you the rules of filling the electrons. Rules of filling the sublevel in orbitals. Let's suppose there's an element, different elements. Let's suppose first one we take chlorine. So 1s2, first we take a chart: 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6, 5d10, and 5f14, and so on. Okay, now we just round a circle around each. Okay, we mark the arrows. We just mark the arrows. Let's suppose we mark arrow 1, 2, 3, 4, 5, 6, 7. We just mark 7 arrows. Okay, we just follow the rules of arrows, not the rules of its continuity. We just doesn't follow the rules of this continuity. We just rule the arrow. Those orbitals which comes in the in between its arrow, so we will take first. When the electron will be filled in each orbitals to the lower energy levels, electron will be filled with the lower energy levels to higher energy levels. Okay, let's suppose we have uh, sodium metal, or let's suppose we take as a high mm, uh, this is an X element and it has a value 31. Okay, so atomic number 31. So first we see it's all about regarding its structure, electronic configuration. 1s2, 1s2 come first, then 2s2, 2s2, then the mark the arrow 2, 2p6, 3s2, okay, 3p6, but after 3p6 4s2s come. Okay, 4s2, because after 3p6 3d10 will not come. 3p6 we mark the arrow, this as it. So 1 2 3 4 5 6 8 9 10 9 12 18 19 20. Okay, now 3d10, 3d10, and after 3d10 it's a 4p, 4p1. Why this 31? Okay, so we just fill with the help of that. But how it can be filled in the orbitals? Okay, 2s2, 1 2, 3s2, 3p6, okay, so we just fill it like that. First one is, this is 1s, okay, 2 electron filled. This is 2s, 2 electron filled. This is 3p6, this is 2p. Okay, so 6 electron, how it's filled? First is on px, second on the py, and third on the pz. Then after filling that, then they fill px again. Okay, 3s2, that's the 3s, 3p6 again, 1, no, that's wrong, 2, 3, 4, 5, 6, that's 2, 1, 2, 3, basically this is d orbital. Okay, this is 5, then 6, 7, 8, 9, 10. We doesn't feel like that. Okay, well, once all single electron is filled on orbital, then it's refilled. And what is its px? Okay, so this is filling of electrons such like that. This is basically okay. So here is basically all of the about electronic configuration. But the electronic configurations gives you very great informations which we often ignores. Let's suppose if X is a 31. So what it gives you the information that it is related to group, it is related to period, block. This element related to P block. Basically, it have P block element. Okay, its group, its period is 4. Okay, its period is 4, and we just make the value 8 2 in K shell, L, M, K. Okay, 2 electron comes on K shell, 8 electron come on L. See, this comes on M, 8 come on N. Okay, and how much did 2 to 3? It means 3 is left, so means it's group 3. Okay, so with the help of electronic configuration, you can find the groups periods, and block. So today we just studied that what is electronic configuration and how we can fill the electron in the atom, and what types of information the electronic configuration we will get from it. Thank you very much. Hopefully we will come from the next topic. Thank you very much.